So today I'm going to be doing a couple of questions, and the central theme is going to be around completing the square. Now, as you can probably see from this example up here, it's not a complete the square question, but nonetheless I want to go through it just to have a basis. As we know, the whole premise of a question like this is to find two numbers that multiply to 9 and add up to 6. In this case, it's a very obvious example. 3 times 3 equals 9, and then if you add them up together, you get 6x. So the solution just becomes like this. Well, not the solution, but I suppose the equation. Then, of course, you can find the solutions by taking everything to the other side, like this. You get x equals minus 3. This scenario is what we call a perfect square. Why? Because we get, put this out, we get x plus 3 times itself twice. And then we can do expansion, and we get this up here. The reason why I wanted to show this is because the whole premise of completing the square is turning a difficult example into a perfect square, into something that's easy. So that's what we're going to go through now. Let's have a look. Let's go from the first example. And the first example is going to be x squared plus 6x plus 5. So instantly what you can see is that there's a problem with this question. The problem is you can't obviously think of two numbers that multiply to 5 but add up to 6. In the previous question we could, it was quite obvious, but in this scenario it's not. So this is where you have to do the process of completing the square. And this is what it involves essentially. Like I said, creating a perfect square. What we do is this 6 in the middle, always the term in the middle, the 6, you halve it, you get 3, and you square it, plus 9. But in an equation, you can't just add random numbers. If you're going to have to plus 9, you're also going to have to minus 9. Then we continue with plus 5. Now, as we can see, we saw this before. This is what we had previously. This just simplifies to x plus 3 squared. Then we have minus 9 plus 5 equals 0. We continue. X plus 3 squared minus 4. That's our equation. Now, once again, we can take everything to the other side. So let's do that. X plus 3 squared equals 4. X plus 3 equals plus or minus. Don't forget the plus or minus. When you're taking the square over, it's got to be plus or minus. Plus or minus the square root of 4. This then becomes x plus 3, oops, not plus 3, x equals minus 3 plus the square root of 4, which is 2, or x equals minus 3 minus the square root of 2, the square root of 4, which is 2. This creates our final two solutions that I'll put up here. Minus 3 plus 2 is minus 1, or minus 3 minus 2 is minus 5. And these are our solutions. Bingo. Easy. Now, we're going to go into more challenging example. 3x squared plus 12x plus 7 equals 0. Now this one's a bit more challenging, and the reason why is because it's got a coefficient. An A here, this is A, this is A, this is B, and this is C. We've got 3 here. So what we simply do is we take out the common factor. 3 squared. For this one here, we've got to think, what do you multiply 3 by to get 12? 3 times 4. 4, 8, 12. The answer is 4x. Now, since we've got the 4 here, we can do what we did previously. Half, then square. We add a plus 4. But if we add a plus 4, then we've also got a minus 4. Close bracket. And the C component of this equation goes outside the brackets. This is very important, and you'll see why shortly. We leave this over here. Equals 0. Now that we've done that, as you can see in this example, we have a perfect square. Let's draw it out. X squared, x, x. What multiplies to 4, but also adds to 4? Answer is 2. 2 times 2 is 4, and then 2x plus 2x equals 4x. So now in the brackets, we can add an x plus 2 squared minus 4 plus 7 equals 0. Now that we've done that, we can multiply by 3. So we multiply these two terms by 3. We get 3x plus 2 squared. 3 times minus 4 is minus 12 plus 7 equals 0. If we simplify further, plus 2 squared minus 12 plus 7 is minus 5 equals 0. Bingo. Now we've got the equation in this form. We can find the solutions of x. Let's do that. Take everything to the other side. 3x plus 2 squared equals 5. X plus 2 equals 5 divided by 3. X plus 2 equals square root of 5 on 3 plus or minus x equals square root of 5 on 3, 5 on 3 minus 2, or x equals minus the square root of 5 on 3 minus 2. Could simplify it further, but in this case I'm not. I'm just going to keep it like this and keep it simple. That's the whole gist of that. The reason why we have to keep this in the bracket is because we're eventually going to have to multiply the term, and we don't want to add these together just yet. We only add them once we've multiplied the two terms inside the brackets. We add them together here. And that's essentially it. That's how you solve the question. You take out the the common factor here, which is 3. And that's it. Now you should be able to complete the square. I hope you enjoyed the video. Thanks for watching.